Hi, this is the video for the review preview lesson 2.2.1. I'm going to film the one for 2.2.2 in another video, so it's just 2.2.1 for this lesson. All right, so 2-81, it says, while watering her outdoor plants, Maura noticed that the water coming out of her garden hose followed a parabolic path. Thinking that she might be able to model the path of the water with an equation, she quickly took some measurements. The highest point the water reached was 8 feet. Okay, that seems important, so I'll highlight it here, 8 feet. And it landed on the plants 10 feet from where she was standing. Both the nozzle of the hose and the top of the flowers were 4 feet above the ground. Help Maura write an equation that describes the path of the water from the hose to the top of her plants. And then it asks what domain and range makes sense for this model. So the first thing that I'm noticing here is they're talking about being 4 feet above the ground. So if I were to start sketching this, where the hose is, and if you see like this part of the graph here, we're not really looking at it from down here. I feel like our graph is going to start right here. So I'm going to go ahead and just like make a line, just kind of sketch that. Okay. So it looks to me like our graph is starting at 0, 4. Like a 0, 4. Okay. Then it also says that the highest point the water reached was 8 feet and it landed 10 feet away. So like this tells me here that this would be 0, 0, and this would be 10, 0, or 0, 10, sorry, or 10, 0. Okay. And then if the highest point that the water reached, that would be like right here, that would be then at 8 feet. So if this is, we're assuming our vertex point right in the middle, the highest point, then that right here, this point would be 5, 0. So that would make our vertex 5, 8. Okay, so if we're going to write an equation for this, this is saying we've got y equals a times x minus h squared plus k. To write the equation, we need to have an a, an h, and a k. Well, we already have our h and k right there, so those are easy to plug in. I can just write y equals a times x minus 5 squared plus 8. But to have our full equation, we still need to have a. So to find a, I kind of like to think about it in steps. We're going to plug in 0, 0 for x and y. Okay, so this becomes 0 equals a times 0 minus 5 squared plus 8. And that gives us, 0 equals a times negative 5 squared plus 8. 0 equals, and then this would be a and then 25. But we don't usually write it like that, right? Like we're not really going to write 25a. So I'm going to change it to be, a25. We're going to change it to be 25a. All right. So now let's go ahead and solve. And sorry, I meant to plug in a 4 for y because that was the point that we started at. Normally we plug in a little bit. Usually we do 0, 0. All right, then I'm going to subtract 8. So then that leaves us with negative 4 is equal to 25a. I will divide by 25. So a is equal to negative 4 over 25. So now we can go ahead and plug in. Let's see if I can just a little smaller. Fix that. Okay, so now we can go ahead and plug this in. So we have y equals negative 4 over 25 times x minus 5 squared plus 8. And we have our final equation. So when we think about those in steps, so I know I messed up here, but this would usually be like your 0, 0. Sometimes it's other points, but it'd be the 4 in this case. And then usually our second step Well, we can think of it like this, just so you guys have that information. You can think of it as 1, plug in the vertex. 2, plug in x and y. So in this case, we did 0 and 4. Okay. And then 3 would be write the equation. All right. And then it asks about the domain and range. So let's see what makes sense here. So I'm going to write down domain and range. So usually we have something that looks like this. Okay, so our domain in this case here, we go from 0 and then the water lands at 10. So we're only going on the x-axis from 0 to 10. So I'll plug in 0 and 10. And then y, we're going from 0 and then all the way up to 8. So I'll plug in 0 and 8. Okay, so 2-82 says draw the graph of y equals 2x squared plus 3x plus 1. Find the x and y intercepts. Where is the line of symmetry of this parabola and write its equation, and then find the coordinates of the vertex. So this is really not that difficult to plug into Desmos and type out, but I'll show you how to do some of this by hand. First thing, your y, when we're in standard form, y equals ax squared plus bx plus c. C is always your y-intercept. So that would be 0, 1. So you have that right away, your y-intercept. One way to find the x-intercepts would be to go ahead and factor. So I will do that over here just so I have a little bit more room. So we have y equals 2x squared plus 3x plus 1. Now in this case, a right here is not equal to 1, so it's easier to use the diamond method. So I'll go ahead and I'm going to take my a times c, 2x squared times 1, and put that here. So I took 2x squared times 1 and put that here. Then I'll take the 3x and put that here. Okay. So what we want to think about is what multiplies to be 2, but adds or subtracts to be 3. So 1 times 2 is 2, and 1 plus 2 is 3. So that works out, so I'm going to put a 2x and a 1x here. Okay. Now we can make our box, and you kind of forget, I mean, you don't forget about the diamond, but like now I'm going to put my a, I'm going to put that here, so the 2x squared, and then I'm going to take my c and I'm going to put that here. And then it doesn't really matter where you put the other two, but they need to be in one of these, like one of these boxes here. Okay. So now let's think, what do 2x squared and 1x have in common with factoring? I think I could take an x out of both of those. So x times what gives us 2x squared? That would be 2x. And then x times what gives us 1x? That would just be a 1. 2x times what gives us 2x? That's just 1. And 1 times 1 is 1. So that all works out. So I know that this is 2x plus 1 and x plus 1. Let's find our x-intercepts. We've got 2x plus 1 equals 0, x plus 1 equals 0. So x equals -1/2, and x equals -1. So our x-intercepts now are -1/2 and 0, and -1 and 0. So I can write that up here also. Okay, so 1, 0, and -1/2, 0. All right. So then where's the line of symmetry in Wright's equation? So that's like what's in the middle. Okay. And sorry, I meant to write a -1 up here. So let me rewrite that. We've got this -1/2 and a -1 here and here. Okay, so the axis of symmetry, we can use the formula negative b over 2a. So that would be, our b up here is 3. So I'll do negative 3 over 2 times 2, because a is 2. Negative 3 over 4, which we could make that a decimal. Okay, so that is our axis of symmetry and our h, part of the vertex. So negative 0.75, so that's like right in between these here, which of course it has to be like a difficult one, right, with these decimals. So just do your best with sketching that out, because of course it had to be that way. Then find the coordinates of the vertex. So you're going to take what you found here and plug it back into the equation to find y, okay, because this is also like h of your vertex. Okay, so we have y equals 2x squared plus 3x plus 1. I'm going to plug negative 0.75 in for x. So that becomes y equals 2 times negative 0.75 squared plus 3 times negative 0.75 plus 1. Type that into your calculator. You should get negative 0.125. So that means your negative 0.75 and negative 0.125, that is our h and that is our k. So that is our vertex. Okay. So I'll go ahead and get that. It's like right in there. And you can do some checks on, you know, like go ahead and check Desmos just to like get an accurate sketch, but your graph is going to look something like that. Okay, we'll go to the next one, 2-85. So that one says, below are 2 or more situations that can be described using exponential functions. They represent a small sampling of the situations where quantities grow or decay by a constant percentage over equal periods of time. For each situation, we want to find an appropriate unit of time, such as days, weeks, and years, find the multiplier that should be used, identify the starting value, and write an exponential equation in the form f of x equals a times b to the x power that represents the growth or decay. So for part A, it says find the value of a car with an initial purchase price of $12,250, depreciates by 11% each year. So remember, A is like our start value and B is our multiplier. Okay, so when we're using percentages, because it's depreciating, we need to take 100% minus 11%, okay, and that gives us 89%. As a decimal, that's 0.89. That is our B, that's our multiplier. And then here we have A, because that's our starting value. So we'll write f of x equals 12,250 times 0.89 to the x power. And we can just leave it like that. Okay. For part B, an investment of $1,000 earns 6% annual interest compounded monthly. Hint, if you are compounding monthly, your multiplier will not be 1.06. You must first divide the 6% by 12 and then find the multiplier. This will make it a monthly interest rate instead of annual. So that's really important. So that's saying we can't just say because it's growing. Normally we'd be like, oh, well, 100% plus 6% is 106%, which is 1.06. That's our multiplier. That's basically what we almost always do. But this is trying to say, well, actually we're compounding monthly. So we need to take 0.06 divided by 12 to give us 0.005, and then we can add the 1. So our multiplier is actually 1.005. So f of x equals our starting value, 1,000, times 1.005 to the x power. 2-89 says, consider the line with a slope of 3 and a y-intercept of 0, 2. Sketch the graph of this line. Okay, well, this is telling me our m and our b, because that looks like a y-intercept. And because m is 3, I can count up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Could even go back a few. Okay. So we have a line. Awesome. Write an equation, that would be y equals 3x plus 2. Then it says find the first term in the next three terms of the arithmetic sequence t of n equals 3n minus 1. Plot the terms on the same set of axes, and then explain the similarities for part D. So, okay, so this is similar to having an x and a y, except we've got an n and a t of n. Okay. It wants us to find the first term and the next three terms. So we can take 3 times 1 minus 1, so that gives us 2. Then we got 3 times 2 minus 1. Sorry, I don't know why I put a parenthesis there. Which equals 5. 3 times 3 minus 1, which is 8. And 3 times 4 minus 1, which is 11. So these are actually our points. We've got 1, 2, 2, 5, 3, 8, and 4, 11. So we can plot those. But remember what makes this different, because we're looking at a sequence. So it's not, and we're going to talk about that in part D, but it's not continuous. So we're just going to plot the points. We've got 1, 2, 2, 5. And then we've got 3, 8. And 4, 11, which would be right here. Okay, so I'm not going to connect those because, again, it's a sequence. So that's part of the explaining the similarities and differences. We can say one is continuous and one is discrete. They have the same slope. If you can see that, they're both going up. 1, 2, you can see here, they're both going up 1, 2, 3 over 1, up 1, 2, 3 over 1. And you can see that in the equations as well. Okay. Which also, if they have the same slope, they're also then parallel. Okay. A difference, they have different intercepts. If I were to keep graphing here and I went down 1, 2, 3 over 1, we'd be intercepting here. And you can see that also the b is -1. Okay, 2-93 says sketch a graph and draw the line of symmetry for the equation y equals 2 times x minus 4 squared minus 3. What is the equation of the line of symmetry? Okay, so couple things I see here. I see an h and a k. So that tells me that our h and k point, our vertex, is 4, 3. Sorry, 4, -3. Okay, and then it wants us to talk about the line of symmetry here. So that's something we could also use Desmos for, is we could go to Desmos and just take a look and see what this looks like. We could do this by hand, but one thing that you'll see with the h and the k, the h here is also the axis of symmetry. So we can do a dotted line right here. Okay. And it just says sketch a, oh, well, it does say sketch the graph. So let's go ahead and take a look. Let's just go to Desmos. Y equals 2 times x minus 4 squared minus 3. All right, so we've got minus 3. So we've got our 4, -3 point right there. And then I see we've got 2.775 as one, and then 5.225 is another intercept. So we can kind of sketch those just so we can get a graph. So we've got 2.775 like right in there, and then right in here, and then we can just make a sketch. Okay, so the next page wants us to write possible equations for these graphs. So what I think you should do is go to the 2.2.1 Desmos activity that we did. So you can see like we already had those set up for you in Desmos with the sliders so you can play around with them. So what I'll do is I will give you what the equations are and what kind they are, but I think you should go through and actually like look at those on your own. So this first one here is a hyperbola, and that'll be y equals 1 over x plus 2. This one is quadratic, and that looks like to me 1, 2, 3, 4, 5. So that to me looks like y equals x squared minus 5. This one is cubic. So it looks to me like this is y equals x minus 3 cubed, something like that. Again, go play around with the sliders. This one is exponential, and that to me, 1, 2, 3. This to me looks kind of like y equals 2 to the x power minus 3. E is for sure linear, that's nice. So that looks like y equals, let's see what, if we can see what the slope is. It looks like it's 3x and then minus 6. Here this one is cubic, and that to me looks like y equals x plus 2 squared plus 3. Again, go to Desmos, play around with this. Here we've got another quadratic. Here, quadratic again. And then cubic. And remember what it said up here. Write a possible equation, right? So go into Desmos, play around with it, and maybe you're going to have equations that maybe look a little bit different or whatever, but here's hopefully a good starting point for you. Okay, by mistake, Jim graphed y equals x cubed minus 4x instead of y equals x cubed minus 4x plus 6. What should he do to get the do to his graph to get the correct one? So the only part here that's different is this plus 6, and that's actually going to make the graph move up. So I'm going to say move up 6 units. Factoring each of these expressions, look for the difference in squares and common factors. So these are a little bit different because if you look at A, B, and C, we have some, we've got some numbers that are perfect squares and then also some common factors. So because the square root of 4 is 2 and not for 9 it's 3, and then we've got the x squared and y squared, we can actually perfectly split this up to be 2x minus 3y and 2x plus 3y. If you do your box method or FOIL, you'll see that that ends up being that one. Here I can see that they have in common 2x cubed, leaving us with 4 minus x to the 4th. And because of this, you know, the perfect square, the subtraction, and the x to the 4th power, we can also make that be 2 plus x squared and 2 minus x squared. For C, really the same idea. We can split this up into the x squared and x squared, and we can do 9 plus 9y squared and minus 9y squared. Okay. And then here, it's very similar to B, except there's a plus. So that actually does make a huge difference. We can still take out the 2x cubed and have 4, it'd be plus x to the 4th. But with this, there's nothing else we can do. That's it. So did you use a shortcut? I mean, yeah, because I was looking at it and realizing that they all contain a factor that is a difference of squares. Okay, and then 2-100, write an equation for the following sequences. So here I can see that they're minusing 6 each time. So that tells me it's going to be arithmetic, which is this formula here. So because it's minusing 6, and then what would have been the 0 term? Well, that would have been 26, so I'll put plus 26. Here I can see that it is multiplying by 4 each time, so that tells me it is going to be geometric. So that formula is, okay, so the 0 term, if I were to go back, would be negative 1.5. Or to the end. Okay, so I think that is all of the questions for 2.1, and you can go ahead and watch the next video for the lesson of 2.2.2. Thanks.